Okay, sure. So I got
I was thinking that.
But I mean, at first I thought he's like giving it that he used it like that and didn't choose it. I think it's on the side. Yeah, it's a joke.
Yeah. He's talking clearly.
Get a yeah, that, I mean, makes sense. Yeah, they don't have, I mean, we should start on time, right? The sheet should probably know that.
What 32?
Yeah, yeah.
And it's really funny because I would say that and they got instead of certain someone
I thought that it was like a joke of a title or something, like.
Oh, no.
So it's, yeah, so it was the wrong.
It's the wrong title, it's the right draft. Okay.
Okay, yeah, that's fine. But I thought it was like you're saying. Sending out a
Yeah, that's great.
yeah, it was an intended pun or whatever. A very geeky joke.
Yes.
Okay, so we're going to get started here. Please sign the blue sheets and remember the note well that you've seen in every session, most sessions, and the one on Tuesday's session. Apparently we had a little sheet with the title here, so Eric will explain it anyways. He's going to lead a discussion about the
NCAP
design.
document.
Yeah.
Yes, so this is what happens when you try to be efficient and copy paste things and forget to change the actual title in bold on the slide. So this is about the NCAP working group document, not about any other document. So next slide. There's basically one slide. So the fundamental issue here is that we haven't gotten many comments. So if you look at the history here, going back to about a year and a half, right? We did some changes largely from changes in or discussion in Dallas and feedback around that point in time. But since then, there's just been some minor changes about a year ago or last summer, and since then, just keeping the draft alive. So I don't know what we want to do with this stuff. Go to the next slide. So, are there more comments forthcoming for this document, or are we done? I mean, is this something that's useful to just document in its current state? There were some promise is that we would get some MPLS comments, but we haven't actually seen any. So should we pick a deadline for this? Should we use the last call process to say, okay, you think that there's some things that need to be tweaked here? Get those things in. Please send text. I don't have any outstanding items to actually add to this stuff, but if people have things that they would like to see, whether it's sort of, clarifications or whatever, or things that are useful information for people that are doing NCAP that are in the scope of this that we should add, that's fine, right? So I don't know if people have gone back to look at this document, but we should figure out what to do with it.
Atlas. I think we don't want to wait more than, until, say, March in order to get this thing moving. It's been sitting for a while. I think that vigorous arm twisting of people with MPLS clue to look at it and provide thoughts would be helpful. That could include me if you kick me. And but let's just get this moving.
So we should then, should we try to set up some time where if the chairs can solicit stuff on the list? I don't know if you want to have a long last call to force people, like here's a month or whatever, or I want to make sure that we have a bit of a stick to get things moving. But
so my proposal would be to get hopefully discussion going on the list, maybe cross-post MPLS for comments. Hello?
And let's try to identify maybe some individuals who would like to contribute from the MPLS perspective. Stuart is volunteering for that.
Thank you, Stuart. Lou Anderson. So we can take the action point to do a review, one or two people from the MPLS review team.
Yeah,
it should work. And I think the procedure must be like there's a cutoff date before Chicago. You need 3-4 weeks before that to actually update the draft. So there you should put the deadline for incoming comments.
Mm-hmm. So
I heard Aliyah say mid-January or something.
And in parallel, we'll start a process of finding Shepherd and going through quality reviews.
I was going to ask Loa if he was going to formally track it through the MPLS review team process.
It doesn't have to be formal.
Okay.
We need to make sure it gets done, but yeah.
Stuart, would you want to shepherd the document?
Whatever, I'll do whatever you do, but I will do an MPLS.
No. Routing working group shepherd.
Oh, if you want me to, I will.
Thank you.
That's fine. Now, if we ask people from the review team to do a review that is not prior to working group adoption poll in MPLS, it's not formal. It's just a courtesy review that people do.
All right, but note that I'll shepherd it.
So, Laura, thanks very much for volunteering. The issue with this document is not just that it needs reviews, it's that it really needs the MPLS content in perspective inserted into the document. And that's a little bit, I can request routing director reviews. In fact, and so can the chairs, we can cheerfully do that, but it actually needs content inserted.
But there is some stuff, right? Because it has stuff about the entropy label, it has about the control word and whatever.
Right, but
and there might be other things, like if there's wisdom from MPLS that exists at some other document, we can also just add references to that, right? That we haven't captured already. But
I think he used wisdom and MPLS in the same sentence. That's.
Oh, sorry, that's an oxymoron. Okay.
No, Aliyah, you're right. I will ask the reviewers to actually make the MPLS. Help to get the MPLS content into the document. But I picked the review team because they have promised that they had the time to do such work.
Yeah, that's great.
Mm-hmm.
Okay, thank you very much.
So we are going to change agenda a bit. AC had to leave for some time. We'll start with design team review. it would be either Dean or Luberger, and I don't see them.
I'll go hunt. See.
Or we do something else.
Okay, let me see.
Greg Mirsky.
We also have Zhufang. Let's see. So we have a bit of a schedule change due to some unforeseen circumstances. So, Zhufang, would you be willing to present a little out of order? Thank you. Thanks.
Yeah, types.
Yes. Yeah, he'll be pulling up the slides here.
Oh,
Are you frozen or no?
we start. Morning. I'm Xufeng Liu, a member of the Yan routing area Yan architecture design team. So this is a part of the Yan design team work. We noticed that we have many models currently being developed in the routing area. Many models share some similar or same types, but in each model, oftentimes they are defined in a similar way, but differently. All those types, we're trying to collect them into this module, so that we can share among those different models, so that we'll get a consistency and so we can have a common type. So this is analogous to some other common types, like we already have IETF Yan types, which is common for all Yan modules. And we also have IETF INET types, which is for the networking related. Here, we're trying to define the types used in the routing area for different protocols and other models. So these are the types we currently covered in the draft, including router ID, address family, route target distinguisher, bandwidth, link access time, and multicast source address, and also some timer values. I'll go through some of them, key types. So first, the route ID. This type was discussed, I think, several months ago among many chairs and ADs. So the conclusion was we use the dotted quad. So this type is used as the representation of the 32-bit integer, but it's not routable, just a notation for this integer. And so many routing models using this, including OSPF, BGP, RDP, and others. So the next type would be the address family. So this is pretty much copied from the IETF routing, and we added some more types. So each routing area models can customize based on this and get its specific usage. Then we got the route target. They are used. This is used in the BGP and VPN related models, including layer 3 VPN, layer 2 VPN, multicast VPN. We define the type expressed in string format, so they can cover the type 0, 1, 2, and so you have an example here. You can have different kind of formats like 100, 100, or with IP address plus a number. So similarly, routing distinguisher is also defined this way. They are also used in the similar models. Then the next type will be the bandwidth. This is used in IGP models, so especially OSPF, TE-SSS, and RCP-TE. And the protocol contains this field at the 32-bit floating point in the IEEE format. So we specify that in the string representation can be converted to that IEEE format without losing any significance. So it will be exact mapping. So that's the purpose of that. Then the link type is used currently within some models, including OSPF, ISS, and the TE topology.
Question: non-broadcast multi-access type.
Non-broadcast NBMA, it is there. They call it non-broadcast. Then we have multicast source address. So this type mostly used in the multicast related protocol, including PIM. I think it's wrong. So it's IGMP, MRD, and MSDP. So the last, this one is wrong. Okay. And so we have IPv4 and the IPv6 format. So one thing we may want to discuss is that here we don't have the multicast group address here. And initially, I thought we thought that address probably belong to INET types, but the INET types are already defined. So we need to consider, do we want to include the group address here, or we leave that out for the further augmentation to the INET types? It's up to the discussion. Then we have various values for the timer. So we can have timer multiply, although this is timer value, give the different formats that we can have different variations, seconds with the 16-bit or 32-bit or milliseconds. So a lot of protocols have those kind of timers. If we want to use this, then they can be more consistent. But this is multiply also is used together with the timer value. So those are all the types we currently have. And so we need to work with all the model writers. So if we want to use this, then proper models should use the this type instead of this module instead of defining our own. We welcome all the comments, and so it was to mention that because so many models are progressing, so it would be good to have this draft go in sync with them.
I have a comment. Do you specify the bandwidth value if it's bits per second or bytes per second? Because it's somewhat confusingly bytes per second in the RSVP documents, and
right, I see both. That's the thing. So I see kilobytes per second and bytes per second. Do we want to make them?
Well, it seems
Here,
like
here's the bytes.
So here it's explicitly bytes.
Yeah.
I suppose, but so I'm not sure if it's in the text, but so bytes per second would make sense given that that's what's used at least in the RSVP text.
Mm-hmm.
But if it's not explicitly there, I would put it there,
Okay.
and not just the conversion that is in bytes per second. Does
Okay.
that make sense?
Yeah.
Oh yeah, I apologize. I see the text there now. It's bytes per second.
Okay.
So yeah.
Jessica from Huawei, I have some question. Do we need to add the root the type for RSRID? Because I know I found
RSRD
the
support you the router
root
ID.
Yeah, but I think in MPLS terminology we use RSID pattern.
Well, you can define the leaf named as RSID, but the type is a router ID.
Okay, and another comment is if for ARDP, perhaps we can define the how to that is I forgot that means the root ID plus the label space.
Label space.
RDP ID.
And that's specific
need
to
to
RDP, and even for that, I think in the RDP model we are not using that.
Okay, thank you.
Mm-hmm.
Stuart, Brian, I'm rather curious as to why you're doing a bandwidth in bytes per second. Maybe I've missed something. And isn't actually bytes per second ambiguous because it should be 8-bit bytes per second?
So it's following the precedent set in RSVP and the values advertised in the traffic engineering TLVs. So
right.
I think it's generally understood that those are 8-bit bytes in networking world. But if we needed to clarify that, I guess we could.
AC Lindum, I think we should just put that, you know, the convention we've been using to avoid this ambiguity that preceded the base documents, like the original traffic engineering documents, is octets.
Yes.
So let's just use octets in this one, because we've used that in every for the last 5 or 6 years. It was before that we used bytes and just assumed that they were 8-bit bytes.
Okay.
I was just going to say, yes, octets is the internationally known term for 8-bit bytes.
So if you think, yeah, that's doable. So just change from bytes to octets.
So normal comments. Very useful document. Finally, we see some standardization across different terminologies. And we don't want to have more discussion about what router ID is, right? It should be defined once, not per protocol. So great work, and comments from any other working group looking at what's been missing, what should be adjusted. More than welcome. I think we would want to adopt this document by next IETF.
Yeah, we're doing an adoption call, yeah.
Can you just
AC?
repeat what you said about adoption?
So we would like to do an adoption call, poll for adoption sometime before the next IETF.
Thank you.
Okay.
AC, are you ready? You feel okay?
Excuse me? What, do you have a comment? No? Go ahead.
Benoit Claes speaking, so the Ops AD. You know, I'm wondering, why do we have to wait, right? In this hackathon, we did a search tool for all the Yang models. I was checking in that search tool, I could do router ID or router star ID, etc. on the type def on any Yang models, right? I was checking right now, apparently we have only one in OSPF, but I'm double checking. So, you know, the value of this document is to make it quick. These are just type defs anyway, right? And we want to reuse them. The longer we wait, the more chances we're going to have, not only here, but in the industry somewhere, people define their own type def.
So you're suggesting that we do the adoption call sooner?
Oh, yeah.
Okay.
Tomorrow's nice.
Yeah, so the intention is not to wait till forever, but just to gather all the missing comments. That's all. We
Right,
want to
right.
proceed
And
as
you
soon
will
as
get
possible.
all of them by, maybe not tomorrow, but Monday.
Okay, and you will make sure that they're all there, right?
Sorry?
You'll make sure that all the comments have been received.
Do you want to ask to see if there's objections or support for that? Did you ask? Did I miss it? I'm sorry. I walked in 5 minutes late. This is Lou Berger.
So, is there anyone objecting to adoption of this work? Great.
You don't technically have to go to the list. You could.
Yes, we will.
Authority.
You can't satisfy everyone. So yes, we will of course do that. That's what we were originally discussing, but we wanted to take advantage of being here to get some of the feel from the room as well.
Okay, I've just got an update on the keychain model, and you can see the authors here. We did a working group last call on it. We had some discussions and decided to pull it back due to the fact that we wanted to change the structure based on the other models that were using it to have separate trees for configuration and op state. And what we're gonna do is we're gonna do a quick review on the changes. There's one issue that I think I'd like to get people's opinion on in a second working group last call. So like I said, I split it in separate trees consistent with IETF routing, OSPF, ISIS, and the other models. And what we had before was we had a collapsed model, but the bad thing about it is we would only give the intended config. There was no applied config because we don't have revised data source yet. So it would have only given you what you intended. Here's the new key diagram with the state. You see you have separate ones. Now what else is different? For each, this change wasn't actually in the last revision. This was in the revision before that, but it wasn't in the IETF. We added a field to the operational state the last time the keychain at the keychain entry, at the keychain level, not the keychain entry level, when it was last modified. And then other op state we have a Boolean, two Booleans, whether the key entry is currently valid for transmission or currently valid for acceptance, which basically just checks to see if the time that's configured on the router falls in the window of the accept time or the send time, and does that in the operational state as opposed to making the whatever management application query the time and doing it themselves. The key strings, this is one thing. This is the one thing I'm wondering if we should have done that. We do not return the key strings in the operational state. This is kind of consistent with MIBs. We've always said, okay, the configuration, you have the key string, but when you retrieve it, you don't. And I don't know if that's even makes sense anymore. We did it pretty much just to follow MIBs. We also have, as a feature, a way to encrypt the key strings. And there's a reference to the RFC on encryption of key strings. And the master key for the encryption of the key strings is not included in the model. That has to be passed through some other, discovered through some alternate channel. So I'd like people to think about that. Right now, the config state has the strings. The operational state does not. And that's it. I guess we just did the first one, and so we got the second two, working group discussion and second working group last call. Okay.
Do you feel you need to solicit feedback for the string in security?
I could ask Brian Weiss, who used to be the CARP chair.
It would be great.
Yeah.
Any questions, comments?
So we'd be conducting a second working group last call once you get that feedback.
Yes, and hopefully people will take a look at the new model.
Okay.
Given that we have a keychain ref, none of the changes impacted. Well, actually, it was a ref of the config. None of the changes, I believe, didn't impact any of the models. Okay. Now, as you know, you saw the announcement. We standardized IETF routing, and one thing we were talking about, we really didn't put anything in that model that wasn't supported in a Linux system. In terms of what was in the RIB. So after that, we said, well, you know, most RIBs on networking boxes have a lot of these things. So we defined what we thought was a set of extensions that most networking products support, and that could be up to date. This is one thing that's not as we want to get some feedback. We're not even asking right away for working group adoption right now. At least I think we are. Maybe I didn't make the slides, but it's extensions to the RIB that aren't in RFC. I believe it's 8022 IETF routing. So for the next hops for static routes, we added a preference and a tag. The preference, that's what we call in Cisco, we call it administrative distance, but this preference is consistent with the IETF routing. And a tag is an administrative tag. Just about every implementation of a router supports a single tag per route. So what you would use this for is you could configure multiple routes, and depending on whether the next hop is reachable, you would have a backup one if it weren't, and the static routing protocol could install the backup route. Okay, for each route now we added a metric and a tag, and for the for each next hop we added a repair path. In other words, a backup next hop for something like fast reroute. Right now we only have we support the base model in IETF routing supports ECMP, but none of these doesn't support a tags or metrics there either. So this is in the op state part of the model IETF routing. And like I said, it's basically the same as the normal path. Now, one thing about a repair path, especially is you might wonder why we have a metric. That can be interesting, what the metric is, especially with things like LFA, what the metric is of the repair path for a given next hop. So we put that in there as well for the operational state. Okay. We're looking for people, you know, if suggestions on what else should go in this initial set of enhancements. I don't know if I want to do things like everything I2RS has with this set. I'd like to have that as a delta on that, like things like I2RS lets you just define filters and tunnels. In other words, you can add a route that auto creates a tunnel. And I don't think that's supported by simple networking devices. Or actually, I don't know of a network device that supports tunnels through the RIB, tunnel creation to the RIB, but the I2RS model does. Yeah, like I said, I'm not asking for, what I'm asking for right now is review, not working group adoption, because this is brand new, and we'd like to get, our goal is to get an initial set of enhancements to the RIB that are supported by most networking devices. I'm not talking about only carrier class routers. I'm talking about like routers like a enterprise router or a Ethernet switch that has integrated routing.
So I believe ITRS chairs were wondering about need of this model on top of their existing RIP models and how those two would interact. Have you talked to CEO Ross?
We could start a dialogue. They did mention that this was interesting. We didn't get down to the details. Yes, so
Would be
so I
great.
have talked to them, but we didn't talk specifics. So we
Please
could
do so.
Okay. But like I said, my opinion is that the I2RS augmentation should be like, especially some of these things like filter ribs and automatic tunnel creation shouldn't be, at least not unless they're featured. So you know that you can add an end cap to the rib in the I2RS model and you automatically create the tunnel.
No, you don't automatically create the tunnel. Oh.
Yes, you do.
There could be different interpretations of that. But what I wanted to say is, sorry, Olia Atlas, I do expect that the I2RS RIB model is coming out of that working group. It is going to be finishing up in that working group quite soon. And so it's very important to have a really good explanation if you think there's something additional, or if that work needs to be broken into features or something along those lines, which is really what I'm hearing you say is, gee, this is really complete and maybe we need to split it a bit into features. I mean, that's what I'm inferring from what you said, but I think that's a conversation that you really do need to have with the I2RS working group before you talk about adopting something which is very similar in scope. You know what I mean?
Yeah, maybe you could provide sort of more background and context on the...
I'd appreciate your
Yes.
review of the I2RS RIB model.
Okay.
I mean, everybody's
the assumption is that that's overly complex. I mean, that's... I think by saying that, you're saying that's overly complex and you're looking for something simpler.
Yes, I'm looking for something that's supported by the vast majority of networking devices. This wouldn't, and then maybe some of these other things, people could augment it with vendor specific for even the more esoteric features that they support. But the I2RS has these other features in it, and I'm not sure. I mean, I'm not against it going forward as a model, but I think we need something simpler for the vast majority of our routers and switches.
So I still hear you saying features.
Okay, features, yeah.
Maybe, I mean, please take a look at it, have some conversations, because everything you're saying sounds to me like there's Yang mechanisms for this called features, right?
Right.
So that is taking the existing RIB model that's being worked on in I2RS and sort of basically making the simple part of the base model, and then making the stuff that's currently considered complex features.
Yeah.
Okay.
I'd at least like to see that approach explored strongly before we develop conflicting models. We've got enough Yang models to do that. It would be really nice not to spend time on duplication if we don't have to.
Okay. I did have one specific question. You mentioned the metric for a static route basically would be useful for
preference.
No, but you have you mentioned metric. So there's preference, which I can see for backup routes.
Right.
But then defining the metric for a backup route you mentioned would be interesting for LFA.
Oh, that's actually in the ops state. That the backup path has a separate metric in the operational state. So let's say you have a backup path. And let's say it happens to be LFA. We're not limiting the repair path to that. In that case, in some cases, it's interesting what the metric is on the backup path.
Right. But that's in this model.
Yes.
Metric. So it would be good to have actually some text describing that use case or a reference to where it is really described, because I can imagine, well, how do you set the metric in this case
Right.
when it's not directly learned from an IGP? Or it's sort of like, yeah, how do you set the metric of an LFA? And if you have multiple IGPs and so on, I mean, what is it actually?
It's what you compute, right? You know that. For in that case.
Yeah, but
I mean, we're not limiting this backup path to. It's not always useful. We're not limiting the backup path to LFA. It's any repair path.
So what do you compute using what
But
method?
we have a it's unspecified, but it's just a backup path, and you have a metric. An example would be the LFA metric that you compute. That's one back, and in that case, it is interesting to have that in the operational state.
Okay, well, I mean, if it's unspecified and up to the implementer to decide, explicitly say that, because it's not clear where you derive the metric from.
Right. Okay. Yeah. I mean, I think given the example, even though we don't want to, originally when I talked about it, the original one had LFA backup path, and I said no, this is repair path. This is for any fast reroute path, not just LFA.
So could you assume it's a metric as computed by source protocol?
Yeah.
Then it would make sense to have it in operational state.
Yes.
So it could be used for comparison and an analysis. So if you could clarify this.
Yep, certainly.
Thank you.
Yeah.
Dean Bogdanovich? Dean? Yeah, it's you.
I'm looking at this and I'm like, that's
Okay.
Yeah, I'm there.
how much time do you have?
35.
Oh, 35. Oh, plenty of time.
So please go in depth in examples, how to use them. So really usability.
Okay. So, hi, I'm Dejan Bogdanovic. I'm presenting on behalf of the routing working group design team. Originally, we were tasked to work on a device model that we could use to use for modeling and combining all the protocols and services that we are modeling here in various working groups. Since our inception, we have added 3 new members, Eben, Zhufeng, and Ying Zhen, and they brought some new energy into it with some new ideas, which have been reflected. Just short, how many people have read the draft? Okay, authors and a few shy hands. Okay, okay, let's go immediately here. So we started with the so-called meta model, and the idea where we would just lay out a basic skeleton, how to organize modules in a single tree. We described it in a draft, and as we were working there, we realized it might be better to break them up into few drafts because we were covering some complex areas, and because of that, we said, okay, for the elements that we are using, we will put them into 2 standard track models, because the logical network element and the network instance were useful to be standardized. For the just generic meta model, we got feedback that it would be better to be done informational. The reason for that is that you can have server-based, and if you're looking at some server-based models, how we were organizing our device model wasn't fitting, the best in. So, and you can have network functions on the server-based models. So having it as an informational was making much more sense. And one other thing that will come out of this working group will be essentially built on the module classification. So there is a draft that talks about module classification, and that was a very high level classification, which was saying this is a device or a service module, and it's a standard module, vendor module, or a proprietary user module. This wasn't enough to classify, and Chris Hobbs came up with an idea to add tags as strings to be for the developers to extend the classification of a particular modules. That would help with the searchability within private organizations. Then you have what is a high-level standard, and then you can subcategorize it according to your needs. Think about it like hashtags, like Twitter hashtags. As we are working on the modules, and because we are not building a fixed tree, we needed a way how we can dynamically, ideally dynamically, add modules to the tree, because you can foresee a scenario where you're starting with one network element and you want to extend that network element with some new functionalities. In that case, you are extending a tree, and how can you do that? This is what, and then we were looking into the schema mount and saying schema mount fits what we want to do, but also we have to work with the schema mount authors and give them some feedback on what we would like to see added into the draft. And
Dan, one correction. We talked to them about regular mount and told them that we needed schema mount.
Yes, yeah. Yeah, correct. Thank you, Lou. We had discussion about the schema mount with them this week, and we provided feedback to the mount authors, and we even have an idea which we will see how to do that further down in this presentation. So the point there is, once you build it, that you can build a tree. Let's say you have a top device tree, and then you can have what you might know as a logical router or a logical system that are built underneath, that top level device tree. And you can have different logical routers. We call them logical network elements that will have different functionalities. And each one, when you are bringing a new one, you want to create that element with the right functionalities that you are, trying to build. The point there is that also as you're building, you have to have RPC mechanisms, how you can read from that, as well the correct access rights down the tree, as well as in how you can provide the augmentations, even with some of your user-specific augmentations modules that you might have in it. So as we were building that, we found out that there is an issue with shared resources. And the easiest one to point out is a physical interface. Physical interfaces always belong to the top level device model. And the device administrator has to, when the new LNE is created, the device administrator has to assign interfaces to that new logical network element. The point there is that you here have a double or dual administration of that node. Now, it's a shared, essentially becomes a shared resource between the top level, between the parent and the child. As we were, looking how to do that, and we had to have a relative path, we didn't have anything that we could fall on that we knew. So Lou looked outside, and he proposed that we would create a similar mechanism like the mode rewrite in the Apache server. That once you create it and you have your relative path, you would essentially rewrite it to you have the fixed path from a device, and when you do the mount, you will be rewriting the path relative to the new route that you have created for that logical network element. This was also discussed with them, and then we will see how the network working group will accept our proposal. The upstate, this is still a unresolved discussion and topic inside the NetMod working group. There is a design team that is working on it, and they are coming up with a proposal on how to do different data stores within NetConf. Because as we are learning, netconf when it was originally designed, it didn't think about the data stores that we are needing today, and especially with regards to the op state, because often, as you know, the running config and your operational are two different things, and we want to make sure that we are always reading the right operational data. The design team came up with a new proposal, and you can see that document in the draft listed up there. And this is if you have any inputs or any comments on that, that would be the right place to provide feedback. There is actually the network IETF routing config has been published. It's RFC 8022. So this is, finally that has been done. So many of the things that we were waiting for to get it finished, we were able to settle how to do the configuration, like the routing configuration management, which was one of the key things for the logical network element, but even more so for the network instance. And on the 6087 BIS, we are still trying to, there's still not real good guidance on when you're modeling how to do the op state. So that is one part that you look around, you look what's the way how people are doing it, and you always keep in mind that sooner or later, once we have it done, we will have to we might have to change op state. And I see now Benoit commenting on that.
Right, so Benoit Clay, so this draft is right now, I have to review it for the AD review. So the guideline is simple, right? For now, whenever we publish models, they have to follow like foo and foo-state. This is the proposal now. It might change in the future whenever we have the outcome of the design team, but for now, that's a guideline.
Yeah.
When do we expect the outcome?
The thing is that there are multiple document impacted. So there is some in netconf and there is some in netmod. So it's a lot of work. We have to change also the architecture. So I would say 9 months, something like that. Now, if we wait until we've got the perfect design in order to publish those Yang models, as I've been mentioning multiple times, it doesn't matter, all right? And also, I believe that it would be great to have the perfect model to start with. But again, this is like not happening. It's a dream to believe that we'll get the perfect model day one, and because we're the IETF, these are the perfect ones. So the guideline is let's publish what we have right now with what has been working with the interface, with what we did with the routing, a foo and foo-state. That's
so in your consideration, you'll make sure they're backwards compatible. So what's published now won't need to be changed. We've seen people working on op state separation, some other stuff, which it takes additional time and energy, which should have been done in general.
We'll see about backward compatibility, because yes, it will be, but there will be a way to just have better Yang model design if you remove the foo and foo state.
Okay, thank you.
Lou Berger, one of the discussions we've had quite extensively is what to do in the interim. What do we do right now? And should we do something that should we try to reorganize models in a certain way that will help transition when we have the data store solution? And after a lot of discussion, we came to the conclusion it would be best not to introduce any new sort of conventions right now, because we see that there's going to be something that's coming. And if we introduce a new convention, it means that we have to worry about transition or compatibility with what is already in RFCs, like in 7223 and now in routing config, as well as this new convention. So while a new convention might be attractive and feel like it's a good thing to do as a stopgap measure, it actually makes it more difficult. So I'm not so, and you brought up compatibility. And compatibility with new conventions seems like extra pain. Well, compatibility with RFCs, that makes a lot of sense. Yes, we have to figure out how we deal with RFCs, whatever even if it's, yeah, we just keep using them, or yeah, we use an augmentation, don't know. We'll figure that out on the RFC side. For the non-RFC side, we should think hard about introducing anything new.
So there's delta time between now and then. Would be really good to provide some guidelines to consumers, to people who write models, what to do.
And that's
So,
that's why section 5.523 is called out there.
Okay.
And it basically says, don't introduce a new convention. It's not a simple answer. I read it and I don't find it simple, but some people that have done Yang longer may find it simple. But to me, it means you have to really understand what problem you're solving, and then it gives you a couple of patterns to follow, and so follow one of those patterns. And that, again, 523 of the BIS.
Thank you.
On the conventions, this is a new draft. Actually, yeah, this is the new draft done by the new DT members, and essentially you are trying to. They defined an initial set of types that that you can use inside your essentially they have defined an initial Set of Yang data types that can use beside your modules. So I haven't read the draft, don't know the details, but Zhu Feng is here and he can answer your questions if you have any of them.
I recall OpenConfig running into same discussions on what should type dev be. So if someone could communicate, I could potentially do it as well, that there is this model which defines all of them and provide unified view. I think it would be great for everybody.
On the model classification, this is that came out of the organizational model discussions draft. The idea there is that it provides additional flexibility to the model developers to classify it, because the model developers is the best person to decide how it wants that classification to happen. Now, once you get the classification, one of the useful things is if you want to create your own internal private library of modules, and you can then use this proposal to extend it according to your internal or organizational needs. And then it makes it easier to find the modules and reuse the modules down the line. We will have proposal. We are discussing about few things, how we could at least standardize part of it and use some well-known names that would be the beginning, so that you will not have too many variations, but the idea is there to leave a lot of flexibility to the end users. Okay, so in this case here, we will go through the examples on the logical network element, and I will go through much more details in the logical network elements than through the network instance. But both of them are pretty similar, and I will explain the main differences between two of them. Just a quick time check.
18 more minutes.
8 more minutes. Okay.
18.
Excuse me.
18.
18. Okay. So the device model 01 essentially is how this is the model that defines how multiple different models fit together on a single device. So the top level model is the one that will take care of all the hardware. It will take care of the chassis infrastructure. This is where you can describe that in the top level model, and you can view it as your bare metal server. Now, once you have that bare metal server, you want to spin up different routing, essentially network elements that will provide you different network functionalities that you're looking to do that. As when we were working on that, and we wanted to add that it was becoming more and more complex as from a standardization perspective. And then we said, okay, let's leave it just as a high level reference idea, and essentially take out the logical network elements and the network instances out of that draft, create them as standards drafts, standard track drafts within the IETF, because the logical network element and the network instances are something that we know how to build, but we don't know where those can be hosted. So that was our main idea behind splitting it into multiple drafts. On the ILNE model 1, the version 1, okay, so actually let me go forward and then try to explain you a little bit more about the logical network element, because not sure how many of you are familiar with the term. So the idea is that the logical network element provides administrative separation between network elements that are on the same device, or it can be also on the one device, but it's you have a full network routing and switching separation within that. And you can as I mentioned, you can compare it to bare metal server and the VM. Once you have it assigned to you as an administrator, you have a full rights to do within that LNE what you want. Now the top level device administrator assigns you the resources for your usage, and after that, based on the capabilities and resources that they are available, you can build your own custom LNE that will satisfy your functionality. Now, how it was designed, this also enables you to do recursive LNEs, because there's nothing stopping you to create another LNE within that LNE that you have created. So what we really wanted to create is, here's the basic structure, how to create a logical network element, and then you can easily extend it with functionalities that you need. You can extend it with routing, RIB, switching, but you can then also create new network instances between this network element. You think about it, you have a full router that you can decide what you want to turn on or off. Here's an example that when you are creating, when an LNE is being created by the device administrator, it will say, here's a logical network element. I'm giving you some name. Is it managed or unmanaged? Let's keep it for the moment that it's unmanaged, and a description, and says, this is your root, and this is now your relative root for all for the LNE that will be created. Now, once that root is created, did I build it up or no? Okay. So now so once this root is created, the device admin, once this is created, it's being assigned to the what I call a tenant admin, and now I can start managing that LNE that is rooted, up there. And now I'm saying I'm using the schema mount, and I'm adding, let's say as an example, static routes, and I'm adding a RIB in order to be able to manipulate this information. What I'm doing here is I'm binding it to the LNE name that was created by the by the device admin, and so far so good. In order for this LNE to be able to communicate with the rest of the world, we need an interface. And the interfaces always belong to the top level LNE. Essentially, they belong to the device administrator. And the device administrator has to assign interfaces to the child. Now, here we will just say a physical interface, and the administrator assigns a physical interface, uses a schema mount, binds it to the LNE name, and this is the administration has been passed down to the tenant admin. The tenant admin sees it has a physical interface and says, I want to enable that physical interface for VLAN. And I then also want to create, as a next step, I want to create multiple VLANs on this physical interface. There is a problem because, the schema mount, it was something that we needed in order to get it done, and The other part also here is with the yeah, so was the XPath issue, because we couldn't have a, the point there was that the device administrator has still the full administrative rights of that interface that was assigned to the tenant admin. And now the question is, how can we make sure that the access rights are to the, what is the tenant admin doing with that physical interface, how that can be managed? That can it be just viewed as a black box, or it can be visible? How to deal with the upstate? Some of the upstate information has to be visible by the device admin, the top level admin, because there will be a lot of information coming from that interface, and it can impact, you know, the overall upstate on the device. But some of that information is also needed by the child. We had some discussions with the network access control management people in the Andy Bierman in the NetConf working group, in order how we will be able to manage the access rights between it. And this is, for example, when it's a non-managed. There is another use case when the device administrator is managing the tenant device. Then again, what will be seen where, you know, and how to do the separation between the information of the multiple LNEs. Any questions? Makes sense? Okay. Just a second. So
just for a little audience interaction, I guess I'll come up with one. You mentioned the hierarchy, and I think you said you can make LNEs within LNEs.
yes.
Oh,
This is
coming
just
up
about
here.
this
Okay.
where I'm going. So, for example, I have a top level LNE that can be a physical or a logical LNE. And down here at the bottom, you've seen like interfaces. Now I can create one or more child LNEs within the top LNE. And then the child, I can turn a child LNE into a top level in the parent LNE and creating further child LNEs within that LNE. So if you, as the closest example that I could come up with would be, I'm on a bare metal server, I'm creating a VM, and with that VM, I'm spawning off multiple containers.
Are you going to limit number of recursion levels within LNE?
No. Because the whole point there is that depending on how many resources you have, you might then decide, oh, there is a physical device administrator, and let's say I'm getting the whole device as a customer. In that case, I am managing I was assigned those resources on that physical device, maybe just on the front end. I can have now the freedom how I want to reorganize it. Do you want to have one big LNE with multiple sub LNEs? I can create different kind of topologies within that. So, and then, you know, because if I have enough resources, there's nothing preventing me to do that. Okay. So, as mentioned, the notable topics, what we're trying to figure out how to do is assigning resources to the child LNEs. Those would be interfaces and QoS. The point there is that you can create a policy, you know, like a QoS policy, but then you want to apply it. So that's a question, because the question is here, how can you share the physical properties of the QoS with your logical, you know, policy? And also, the other part is, which I mentioned a little bit before, was how to provide the correct access to the tree and have the use cases where it's managed versus unmanaged, and passing of the operational state data correctly. So those are all the issues that we are currently working on. And again, if some of you have some good proposals, we would welcome, you know, coming up with the idea, or if you did something like this, implemented something similar, we would be curious to hear more about your experiences. The network instance is a pretty similar situation as with the LNE, but with one differentiation. The network instance provides only switching and routing domain separation. It doesn't provide any administrative domain separation. So that means within a single administrative domain, you can have multiple routing or switching domains. We didn't call it the routing instance or switching instance because we want to be agnostic if it's a layer 2 or a layer 3. The network instances at the moment, how we see them, they can be only part of a single LNE. Me personally, I don't see a use case where a single instance could be member of multiple LNEs. Here's an example, of a network instance model. We are using, the schema mount as in the logical network element. Just what we are doing here differently is that we are creating essentially when we create a network instance module, we are then attaching it to the interfaces, relative to the root point that where it was created. And the network instance will be created inside the logical network element. And that's the end.
AC Lindum, I'd just like to point out that the slide back on schema mount, where we're still looking for the solution, you can see we're augmenting the interfaces. Now, the way schema mount is defined right now is when you mount a network instance model, and someplace within LNE, you re-parent that model at the mount point. Now, in this case of the interfaces, as they are in 7223, they're at the root of the device. So that's the problem that we have open.
I'll ask questions. Audience. Connectivity between LNEs or NEs, how do you envision?
Connectivity between them?
Yeah, so if you want to have logical.
So the connectivities, you because everything is going through the physical layer, how will you can then have at a layer 2 or a layer 3 connectivity between the LNEs by combining them on the, by using the physical device to connect them. Because you're defining this interface and this interface belong to two different LNEs, but they are part of the same VLAN or the part of the same subnet. And then you're establishing a link between them and you have connectivity between them. This is essentially from the transport. And then from a management perspective, you could make that they are part of that you're a managed network service provider. And then you have LNEs to belong to different customers, and you want, or one is yours, one is of your customer, and then you want to manage them jointly because it's a managed, it's a managed service.
AC Lindum, somebody doing like a virtual interface that connects LNEs could be an extension, but we're not including that as part of the base model.
So for inter and NAC connectivity, I assume you could do something like VRF Lite and terminology of vendor.
Yes.
Thank you. Very useful. Great stuff. Greg Mirsky.
So we're running 5 minutes fast or 10 minutes fast, but so is Greg Mirsky here yet? We're running about 10 minutes fast.
I have to reply to ACES.
Okay.
Our model, as it is, supports this connectivity of creation, because what the administrators within the LNEs will do is is completely up to them, and they can create those connectivity using using the physical device to for the data transport.
AC Lindum, but I think what Jeff was asking about was not having a wire between them, having like a virtual interface, like a lot of proprietary products implement between their virtual router instances and internal.
You you don't have to put them in the wire. You can just put them in the same VLAN.
Lou Berger, either way, you would separately configure those.
Yes.
Whether it be a null net or an actual VLAN, doesn't matter. You would just separately configure them.
Yeah. So my question was more in terms, would you create special type of interface, which is virtual router interface, intercontext interface, or just use common VLAN-like interface to provide the
It's it's an implementer's choice what type of networks they support, and certainly Ethernet is a standard interface. If we wanted to have loopback as a standard interface, you could configure it on loopback interfaces.
Okay.
But that's outside our model.
Sure, understood.
So why don't we go ahead and do the sort of advertisement and discussion for the virtual interim.
Greg is here.
Here's Greg, so
Just
we can,
that.
yep.
CCV or header? What do you prefer?
Yeah.
Just a second. It's coming in.
Okay, so these two presentations been already discussed yesterday at NVO Group, and so I apologize up front. I know that many of you work in NVO3 group as well, but a little bit history. We had overlay OEM design team working on this and update for what we've been presented in Berlin. The proposal was to have OEM header that immediately follows overlay network header. Originally, we opted for 32-bit word that includes version number, message type, length, and flags, but that forced us to be very limited in future options and extensions, and after discussion decided to go for 2 words and expand on message type, space, length, and flags. We left the reserved field without merging it with the flag. So originally we gave all this possible space to flags, but then there was a proposal by Dave that to have reserved space and later decide how to use it. One more addition to this structure is next protocol field. And next protocol field is meant to play some role if this to be used as in situ OEM header. So then it will look, what will it look like that we have overlay network header followed by OEM header, and that will have the next protocol field telling us what the payload is after OEM control message. If it's pure active OEM, then the next protocol field will in OEM header will be 0. So this is the intention. And we always looking for reviews, comments, suggestions, contributions. And as we asked yesterday, for the working group that will agree to consider adopting this document Okay, any questions?
Who have read the draft? So we are going to poll it on the list, but who thinks it's time to adopt, there's interest to adopt, to work on it? Thank you.
Yes, actually, one more comment. Yesterday, there was a question of where we would like to have a discussion of these documents, and we agreed that it will be Rtgwg list to discuss overlay OEM documents.
So when you refer to yesterday, what are you referring to?
I'm referring to NVO3 discussion.
Okay, okay.
So at NVO3, we asked the group, the community, to send their comments to Rtgwg list.
Okay.
So, sorry, but we volunteered your list.
Okay, okay.
Okay, let's move to the next presentation. Thank you. Well, that's an update on another document that we're working on. And originally, we referred to this as overlay ping traceroute, but then we realized that ping traceroute, it's a little bit well, there is a historical reason. We all understand what it means, but we changed the terminology now, and we refer to this as AGROC request reply. So we clarified some of description of the mechanism and how and where their control message follows. So the control message follows OEM header, and that makes it possible not to require any IP encapsulation. So if you're familiar with the MPLS associated channel, that very much makes it work as MPLS associated channel. Use of OEM header. Original version. So in this presentation, didn't copy the format of echo request reply, but so the original version has the format already specified. And what we've done is we expanded and detailed IANA consideration section on where message type and other fields will require IANA consideration and how the ranges will be controlled. Another change is security considerations section. So since this is an overlay mechanism, then it clearly that it will inherit all the security considerations that are characteristic to the transport network and to the overlay. But at the same time, since this is an on-demand mechanism and the processing is intended in outside of the data plane in the control plane, there is a denial of service attack vector, and there is a possible replay vector. To mitigate these vectors, we just list possible ways of protecting. One of them being rate limiting. Another is using their sender handler, which is more like a test session ID and a sequence number to protect against replay. If it's not strong enough, then in this document, we introduce optional timestamp record that can be used to provide stronger protection. And again, we appreciate reviews, comments, suggestions, contributions. What we're planning to do is expand on types of operations that can be done with the echo request reply. And again, consider for the working group adoption.
So same set of questions. Whoever has a draft? It would be really good to see more people reading and providing comments. Thank you, bro.
Thank you.
Okay. So we're ready to do the, yeah, okay. So there was discussion in IDR on, I guess that was Tuesday afternoon or Wednesday, I can't remember actually, related to in the context of the BGP SPF draft, where Alvaro suggested doing a virtual interim in Rtgwg to discuss the problem that that draft is trying to address, and there's also some other work going on in the IETF along those lines. So we're planning to do a virtual interim in January. And at that point, what we really want to do is focus on the problem. That is, what's the need for new work in the routing area on data center underlays? And in focusing on the problem, really try to hear from operators or people who have at least been, interacting with operators about their pain points in deploying routing protocols as in the data center underlay. There's a general sense that, okay, there's scalability problems if you try to run, ISIS on 10,000 nodes, but it would be good to really understand what the issues are and the use cases. There's sort of a proof point in that, well, people have been running eBGP between nodes, and we have a draft in this working group that was produced. The authors discussed it in this working group, and we published it on doing just that. So we have sort of a proof point that there's a problem with using just straight link state protocols. So people have used eBGP. However, it would be good to understand, okay, what are the pain points with both of those approaches, and what would a potential new solution do to address that? So I wanted to go back to this slide. So we're really interested in hearing from data center operators, even those data center operators that are developing their own solutions would, I believe, in the long term benefit from a standardized solution. So even if it's their special sauce for the next year or two, they would benefit from getting something standardized as well.
And so RC 7938 BGP in large GC has been really big success, used by many people to deploy, used as guideline how to deploy. It explains drawbacks, when to use, how to use. So we would really like new work to follow those kind of guidelines, identifying problem space and what you want to be addressed by either enhancements to existing routing protocols, so reduce flooding in IGPs, or maybe SPF and BGP or some other completely new protocols which address this problem in a better way.
So we're going to send out an announcement on Rtgwg, IDR, ISIS, and OSPF, probably announcing our virtual interim. But we wanted to use this as an opportunity to, try to find speakers, or if you know of someone who would be a good presenter in this, contact Jeff and I, and we'll either reach out to that person or discuss with you presenting.
Sean Zandy with LinkedIn.
Mhm.
Well, we appreciate the opportunity. One of the reasons that we're using BGPs, of course, is because it's a very scalable protocol for a data center. However, as we know, BGP was designed as an IDR with certain intent. It definitely scales, but maybe it's not the best routing protocol for a data center with a fully mesh, widely class network. So we thought that it would be great if we could, as you mentioned, scale SPF to data center to make better decisions or faster convergence, or having topology information, or being able to export that topology and reconstruct it somewhere else for different purposes, as well as segment routing, for example. However, extending ISS and OSPF is not that easy. And if we could take advantage of those algorithms along with BGP as the transport, that would be very beneficial for us.
Okay. And so can we sign you up to sort of present maybe 20-minute presentation in this virtual interim on on both the problem and the solution you potentially see?
I'll be more than happy. Thank you.
Great.
So since author of BGP SPFs are present and they provide their slides as preparation to a common interim, would like to give them stage to talk about their proposal and solution.
And also to be clear, we're using the Rtgwg as sort of a lightweight mechanism for discussing this work. It's not clear that it would go here, whether or not it would go somewhere else, whether or not there'd be a BOF. But we're using virtual interim to move fast and not wait until Chicago to do anything else. So just wanted to make that clear that we're not saying, oh, this work goes here.
Thank you, Chairs. Good morning, folks. My name is Keyur Patel. I'm just going to go over the problem statement of this draft to give an overall sort of a general idea of where the problem statement lies. So as the chairs and Sean mentioned, massively scaled data centers have implemented some kind of a simplified L3 routing. No brainer there. These days, these data centers are rapidly transitioning towards some kind of a centralized route control model, mainly through some form of controllers. And like it was mentioned before, from an operational simplicity standpoint, most of these data centers have converged upon BGP as their routing protocol. But more importantly, they have come down to a point where from an architectural standpoint, they use only one routing protocol, be it a BGP or be it some kind of an IGP, both as an underlay as well as an overlay protocol. So specifically when you start using BGP, which is heavily deployed in an eBGP fashion, it's today the way it's been deployed, the sessions are set up in band in an eBGP peering form. But if you're going to use some kind of a route reflector, then that route reflector for all practical purposes in such a network will have a functionality of a, the route controller will have a functionality of a route reflector in sense that it may reflect the routes or may not, but it will definitely act as a central database for policy enforcement, management, and any debugging applications that they would need to do. So if you do that, in a traditional route reflector deployments, you would assume that there is some kind of an underlay running, and that would help resolve any next hop adjacencies for the clients. which is missing here, as there is only one protocol of a choice. And as you start to go down this path, it becomes very clear that if you're going to use one protocol, then you need some kind of a directed graph, particularly in case of BGP, to help resolve the adjacencies at the when you start to use BGP as an underlay protocol. And more specifically, you try to use a protocol like BGP, which is not setting up a hop-by-hop session from a peering standpoint. So this is the problem definition we were after in IDR, and it's in context of one specific protocol. In this case, it's BGP. If the data centers do deploy IGPs, the similar problem definitions exist for the other set of protocols as well. And that's all I have. These are the advantages of BGP. We've talked about the advantages of BGP. Here's a slide that also explains why we want to use BGP in context of segment routing, or why it's been used in data centers. And lastly, the questions that the chairs had asked in some form earlier.
So again, the virtual interim, I think, is going to take a step back, try to understand the problem or problems. It could be that there are several sort of data center scaling problems and use cases. It sounds like this particular use case sort of focuses on, starts with the assumption of a particular type of controller and then extends that. Just want to make it clear that we're not saying, oh, this is the problem and we've already decided on a solution. At the same time, we don't want to take 6 months to have this discussion about what's the problem in the first place. So we're moving reasonably fast on this.
Robert?
Okay, Robert Rtgwg. So, I have two questions. One, to better understand, do you plan to have any adjacencies between your hop-by-hop underlay in this model?
Not for the underlays.
Okay, so in this case, if you don't have any adjacency for protocol, how do you run BFD between the nodes?
So at this point, I think we're talking about a particular solution right now, right?
So I have another question, fundamental. Is there any extensions to BGP required here? Because if not, then what's the standard track you're gonna pursue that work?
I'm sure Chris will again tell you that this is again
let's Chris tell me.
But I'd be happy to.
No, if there is no extension.
So Alvaro had some comments on that in IDR, and I mean his viewpoint that he stated at the mic there was that it uses BGP-LS, but is in some sense a new protocol because it's modifying the several rules in BGP. So it might actually be just cleaner to say, this is a new protocol encapsulated in BGP-LS. Anyways, that's paraphrasing what he was saying. In any case, that's open for discussion, and that's why we're going to be discussing it.
So no extensions to BGP modify core BGP behavior. That's why we are trying to spin out and see what is the best way to solve this common set of problems.
Only Atlas. Yeah, this isn't about this particular proposal or its implications, which are, I understand, of great concern to those who know and love BGP, like all of us. But it's more because we're seeing issues around this cropping up with potential solutions or partial solutions. I think you have a slide with like 4 or 5 different drafts that are cropping up in this space, and it seems to be a problem space where there are not yet well-defined solutions that have strong deployment. And so it's a time that would be really useful to understand clearly what the issues being seen are and see if we can, converge before we all decide to go off and argue about our different approaches to the same thing for years.
Yeah. Sean?
Yeah, I just wanted to, Sean's Andy LinkedIn. I just wanted to make sure that we also move this as fast as possible so that we can have interop in our network.
Yes, we agree that moving fast is good on this. As Aaliyah mentioned, in addition to this, the work in IDR, there's also work in ISIS on basically modifying ISS to optimize it for a spine leaf topology. There has also been work presented, or at least submitted to Rtgwg on fault avoidance routing, which actually, as far as the problem description goes, it's provoked quite a lot of discussion on the Rtgw list over the last year or two, and so it's actually, as things stand, the most complete discussion of a problem statement. Whether or not you agree with that or not, it's actually a sort of a reasonable model that we should at least get a problem statement out there fairly quick and argue about it and agree on it, but come to that conclusion pretty quickly.
Yeah, Dmitry Afanasyev, Yandex. Not a question really, but more like a comment. First of all, it's interesting direction, and I see some potentially useful applications for that. Also, I think it's important, even with link state, to keep an option to have hop-by-hop BGP sessions. So they shouldn't be mutually exclusive. And also, besides the data center network, which is very regular, and there are benefits of using SPF there, but it works with even with normal BGP. But it also must be used for DC interconnection network, which is much less regular, and you need something like traffic engineering computations there and so on. So link state might be applicable there. And the last one is realistically, I think there would be a combination of both some link state information and some usual path vector information. And eventually the forwarding state must be computed from both.
Super. Thank you.
So what was your name again? I missed it at the when you. Okay.
Dmitry Afanasyev, I'm from Yandex.
So Dmitry, abusing the moment, would you be willing to present during interim?
Just remind me, please. Interim is when?
January.
January, probably yes, but something really short.
Since most of those comments were relative to the BGP link state based solution that we purposely didn't repeat again. Have you read our draft? Because a lot of the questions
I skimmed through it, but I definitely need some time to go through it again and think of it.
So I just want to summarize something to chairs. I mean, it's a wonderful effort that we are taking here, but please keep in mind that 90% of data center networks run BGP today. So while we look at other things in a holistic fashion, we need a solution particularly for BGP and for other protocols that are out there. And keeping that in mind, we hope we will expedite whatever we need to do here. Thank you.
And actually sort of backing up that number of 90% would actually be, I mean, I bet that's a surprise to a lot of people. I don't necessarily doubt it. However, it would be good to actually sort of.
I take it back. Maybe it's 60, but there is huge percentage.
Okay.
I think AC Lindum, I think in the smaller enterprise data centers, that's not the case. We're talking mainly the MSDCs, the massively scaled ones.
And the point of 60 or 90 was to drive that we are actually trying to solve a deployment problem for the protocols that are deployed, and we know the problem exists.
So the intention is not to lock up into analysis paralysis gaps stuff. The idea is really to progress fast after interim and try to solve real problems.
Thank you.
Want to close it out?
So we are 15 minutes early, which is great on Friday. Thank you, everybody, and see you in Chicago. Safe travel back home. Blue sheets. Has everyone signed?
Yes, exactly.
I had an interesting and really weird thought. I was thinking about stuff. He did that sort of reduction of I was wondering if there was a sort of, and I was quite impressed with how he managed to deduce. So, if you actually got a crypto or authentication system in place